Lesson 4-8, multiplying and dividing monomials. And in this lesson, you learn to multiply and divide monomials. Why is it important? Knowing how to multiply monomials will help you determine the increase of a financial investment. Let's take a look at this activity. In dealing with large numbers and small numbers, calculators can simplify and speed our computation. Okay, copy the tables below, then use the calculators to find each product and quotient and complete the table. So if I get a calculator, okay, and I multiply 10 to the first power, 10 times to the first power, the product would be 100. And if I write 100 as a power, it will be 10 to the second power. 10 to the first power times 10 to the second power using a calculator will be 1,000. This is written as 10 to the third power. This is 10,000, 10 to the fourth power, 100,000, the fifth power, a million, the sixth power, 10 to the sixth power. Okay? And if I do division using my calculator, 10 to the fifth power divided by 10 to the first power, the quotient would be 10,000, or 10 to the fourth power. This will be 10 to the fourth divided by 10 to the first, 1,000, 10 to the third power. This will be 100, 10 to the second power. This will be 10, or simply 10 to the first power. And this is 1, because 10 to the first, or 10 over 10 is 1, or 10 to the 0 power. Okay? So if we are to compare exponents, okay, it says in letter A, compare the exponents of the factors to the exponents in the products. What do you observe? Let's look at letter A. The answer for that one would be the exponents are added. 1 plus 1 will give us 2. 1 plus 2 will give us 3. 1 plus 3 will give us 4, and so on, all the way to the back. Compare the exponents of division expressions to the exponents in the quotients. What do you observe? Instead of being added in letter B, they are subtracted. 5 minus 1 is 4. 4 minus 1 is 3. 3 minus 2 is 2. 2 minus 1 is 1. 1 minus 1 is 0. Okay? So if we write a rule for determining the exponent of the product when you multiply powers, okay, you're probably saying that you are going to add the exponents, okay, and write a rule for determining the exponent of a quotient when you're dividing powers. You'll probably say that you are going to subtract the exponents. Okay, so let's put your rule into writing. Okay, the pattern you observe in the products table above leads to the following rule for multiplying powers that have the same base. So this is our rule now. You can multiply powers that have the same base by adding their exponents. Okay, for any number a and positive integer m and m, a to the m times a to the n is equal a to the m plus n. Remember, important thing here is that they should have the same base. If they don't have the same base, you cannot apply this rule, meaning the a should be the same for both, okay, numbers. So if the bases are the same, okay, you simply add their exponents, become a to the m plus n. Okay, let's take a look at example number 1, see how this works. You are given a to the fourth power times a to the fifth power. Since the bases are the same, first and foremost, we'll copy the problem down. A to the fourth power times a to the fifth power. The bases are the same, so we simply add the exponents, which becomes a to the ninth power. If we want to check our answer and expand a to the fourth, okay, so that's a to the fourth times a to the fifth. Okay, and if you combine all of them, it still becomes a to the ninth power. Let's take a look at example number 2 and how we connect it to algebra. Some monomials can also be multiplied using the rule for the product of powers. Find each product. So we want to find n squared times n to the fourth. Since the bases are the same, we simply have to, okay, add 2 and 4 to become n to the sixth power. That's easy enough. Let's look at letter B. In letter B, first copy the problem, negative 6x squared times 5x cubed. Okay, so we start, we first, okay, use the commutative property of multiplication so that this now becomes negative 6 times 5 times x squared times x cubed using the commutative property and the associative property. Okay, so negative 6 times 5 will simply give us negative 30. X times x to the third power will give us x to the 2 plus 3, or x to the fifth power, product of powers, and you now have negative 30x to the fifth power. So that is the product of powers that we want to, the first rule in multiplication of exponents. Okay, the product of powers. Let's take a look at the next rule. Before we do this, let's analyze this. You can also write a rule for finding quotients of powers. Study the pattern of division sentences below. Each dividend, divisor, and quotient has been replaced with the power of 2. So that's your dividend, that's your divisor, and that's your quotient. Okay? So 16 divided by 2 equals 8. 64 divided by 8 equals 8. We all know that. And 256 divided by 8 equals 32. And we will use this table right here, okay, to find out the power of 16. So 16 is 2 to the fourth power. We know that. Okay, and 2 is simply 2 to the first power. And 8 is 2 to the third power. Okay, 64 is, according to our table, 2 to the 6. 8 again is 2 to the third, equals 2 to the third. 256 is 2 to the 8th power. 8 is 2 to the third, and 32 is 2 to the 5th power. What do you notice about the pattern? Of course, you see a pattern. You're subtracting your exponents. Okay, so in the quotient of powers, you can divide powers that have the same base by subtracting their exponents. Again, the term same base. It only works if they have the same base. If they do not have the same base, this will not work. Okay, you can divide powers that have the same base by subtracting their exponents for any in symbols for any non-zero number a and a whole numbers m and m. Okay, when you have a to the m over a to the n, it's the same as a to the m minus n. Okay, let's take a look how that works in example 3. You have 9 to the 7th power over 9 to the 5th power. Copy the problem first and foremost, and since they have the same base, you can do 9 to the 7 minus 5, or 9 squared. In letter B, okay, c to the 8th power over c to the 8th power. Okay, same base, copy the problem, subtract c to the 8 minus 8, or that becomes c to the 0 power, or 1. And that's the reason why anything raised to the 0 power is 1, because of the quotient of exponents, or quotient of powers, I'm sorry. Okay, and if we check our answer, this becomes easy enough. Okay, you simply expand this. 9 times 9 times 9 times 9 times 9 times 9 times 9, and this is 9 times 9 times 9, 9 times 9. Okay, and we cross that out and put ones. Okay, common factors. 1 more, and we now have 9 to the 2nd power right there. Okay, and that's the same thing with letter B. We expand this. Okay, we cross out everything. You end up with 1. Okay, because well, let me just explain it. So since I explained number 9, C times C times C times C, C times C times C. 1, 2, 3, 4, 5, 6, 7, 8. All over C times C times C times C, C times C times C. 1, 2, 3, 4, 5, 6, 7, 8. 4, one more. And if you notice, they all cancel out each other. They all cancel out. Okay? And since they're all ones, okay, you have 1 over 1 or simply 1. Last example. The intensity of the earthquake is usually measured on the Richter scale. On this scale, the number designation given to an earthquake represents, okay, the intensity as a power of 10. For example, an earthquake measuring 8 on the Richter scale has an intensity of 10 to the 7th power. In April 1992, an earthquake measuring 5 on the Richter scale shook the Netherlands. 12 days later, Northern California experienced an earthquake measuring 7 on the Richter scale. How many more times more intense was the California earthquake? Okay, so what do we know? We know that the Netherlands earthquake had an intensity of 10 to the 4th power because it measured 10 to 5 on the Richter scale, and the California earthquake measured a intensity of 10 to the 6 because it measured 7 on the Richter scale. So we have to divide 10 to the 6 by 10 to the 4th to find out how many times more intense the California earthquake was. So it becomes 10 to the 6th over 10 to the 4th. And since the bases are the same, we simply subtract. And according to the quotient of powers, it'll be 10 to the 2nd or 100. The California earthquake was 100 times more intense. Okay, that's the end of the lesson. Thank you for watching.